Good day, everyone. And we meet again. Right, so the last time we touched on acids and bases, and we're looking at calculating the pH of acids. But this time around, we're going to look at calculating the pH of bases. And for those of you who have not subscribed, where have you been? All right, please do the right thing, subscribe on this channel, and please be sure to tell others about it. Okay. We're doing so much of the physical science, grade 12 syllabus, but obviously this is also relevant for grade 11s as well. All right, so let's get started with it. All right, so today what we're going to look at is the calculation of pH when it comes to bases, right? We touched on acids, but how do we calculate pH of the pH of bases? Now, the first thing that we need to look at is that we know that acids ionize, right? We said acids do ionize, and we said a strong acid is the one that ionizes completely in solution, right? To give us a high concentration of hydronium ions. But what happens with the base? All right, I'm going to take an example here of a base, sodium hydroxide. We say, well, a base dissociates, okay? So if I take sodium hydroxide, how does it dissociate? It dissociates. Notice I didn't say it ionizes. It dissociates, okay? And it gives us sodium plus ions. And now note, I want you to see this. And it gives us hydroxide ions. Now we no longer get hydronium ions, but we get hydroxide ions. Can you see that? Okay, so how am I going to, so in this case, we cannot calculate the pH. Why? Because the formula for pH simply says pH is equal to minus the log, okay? Remember, we said of our H3O plus ions, okay? So I want you to notice that. So remember, for us to calculate pH, we need to have hydronium ions. But look at bases. They don't give us hydronium. They give us hydroxide ions. So how are we going to get that? Okay, so this is how sodium hydroxide would dissociate. But if I take another base for argument's sake, let's say potassium hydroxide. Okay, so it would have to be, it gives us potassium plus, okay, plus OH minus. Okay, so this is how it would dissociate. Okay, so once again, it's a base, but it does not give us hydronium ions, but it gives us hydroxide ions. Okay, so what I want us to do, in fact, let me just add some more bases. Okay, say maybe you've got magnesium hydroxide. Remember, magnesium hydroxide has got two of those OHs. So in this case, how does it dissociate? Okay, it becomes Mg, magnesium 2 plus. Remember, it's on the second period, so that oxidation number there would be 2 plus. And notice, because it has two of those, therefore it would give you 2 OH minuses, right? 2 hydroxide ions. So for every one of that, you'd get 2 of those. But for these 2 that we had, by the way, we know that these ones are the strong bases that we have, right? So for these 2, you only get 1 hydroxide ion each, right? Now, what I want us to quickly do is to quickly look at how would I then, because I don't have hydronium ions, how would I calculate the pH of this base? Okay, so we'll take a few examples in just now, and then we'll look at how then do we calculate that pH. Now, before we calculate the pH of a base, I want us to quickly look at what we call the auto-ionization of water. Okay, and this comes from the fact that when water ionizes, remember water is H2O, right? So the auto-ionization of water is such that when water ionizes, it would give us that H plus, and it would also give us that OH minus. Okay, so this is the auto-ionization of water. So when you pass water through an electrical current, or such that it would now ionize, you get those two, right? H plus and OH minus. And by the way, please don't be alarmed. In some cases, they do write it in this way. So H2O plus H2O, okay, giving us, remember I said to you, H plus and H3O plus are exactly the same thing, okay? So if you look at this, they write it as H2O and H2O, giving you H3O plus and OH minus. And remember what I said to you the last time? H plus and H3O plus are exactly the same thing, right? Now, what was discovered about this auto-ionization constant, of water, is that it gives us a constant, okay? And please, I want you to note this. At equilibrium, when water ionizes, the ionization constant, okay, which is like the Kc value, but in this case they call it the ionization constant, okay, of water, which is Kw, so you can think of it as Kc. Now, how would I calculate the auto-ionization constant of water? It would be, now, for those of you who've watched my video on calculating Kc, sorry, this is liquid, sorry. So this would be liquid and liquid, and this would be aqueous. So this comes in aqueous form, and this is aqueous form. Now, what we said is that when we're calculating equilibrium constant, you never include liquids and solids, okay? We only include gases and aqueous solutions, right? So then what happens? What does that mean? It means that when I take the equilibrium constant of water, of the ionization of water, it would therefore be H3O plus, okay, multiplied by OH minus. And because those two are in liquid form, right, as a result, you are not going to include them, okay? So in the ionization constant of water, we find that water at 25 degrees, right, the ionization constant of it gives us a value of 10 to the minus 14. Right, I'm sure many of you are wondering, but how on earth did they get that value? All they needed to do was just to make sure that they conduct the experiment of water ionizing at 25 degrees, and in this case it gave us a constant. It was a value that they got. They measured it, okay? So they got a value of 10 to the minus 14. And by the way, this is where this comes from. Remember that H2O and OH minus, in this case the concentrations thereof, all right, will give us 10 to the minus 14. Then because they you've got equal amounts of each, that's where 10 to the minus 7 and 10 to the minus 7 came from, and that's why they say water has a pH rather of 7, okay? Right, but let's not dwell too much on that one. Now, how do we use this when it comes to bases? So this is now how we are going to find the concentration of the hydronium ions when we've got hydroxide ions. When we just know this constant, we can now find the concentration of our hydronium ions, and as a result we can find the pH of the base. Let me show you what I mean in a few. Let's take an example of a base, all right, and let's find the pH thereof. Okay, all right, so I say calculate the pH of a solution of sodium hydroxide with a concentration of 0.02 moles. I see I repeated solution there twice, but I'm sure you understand, right? So we want to calculate the pH. Now, first of all, what are we going to do? We want to know, how does sodium hydroxide dissociate? Okay, so what did we say? We said sodium hydroxide dissociates by becoming sodium plus, okay, plus OH minus. So this is what we get, right? Okay, sorry, I just need to zoom in there. Okay, right, so sodium hydroxide dissociates by becoming sodium plus and OH minus, right? So what am I going to say? Well, this simply means for every 1 mole of sodium hydroxide, I get 1 mole of hydroxide ions. Okay, so for any amount, remember this happens in the same volume. So as a result, that's why I can even use concentration, right? So it means that the concentration, now remember, they gave us the concentration of the sodium hydroxide. So this simply means that the concentration of my hydroxide ions, okay, would be equal to the concentration of my sodium hydroxide. Why? Because for every 1 there is 1. Okay? So the concentration of my hydroxide ions would therefore be equal to 0.02 moles per cubic decimeter. Okay? Why? Because for every 1 of that, there's 1 of that. So whatever the concentration of this one is, it will be the same concentration for hydroxide ions as well. Okay, now, ladies and gents, can we calculate pH? No, we can't. Why not? We do not have H plus ions or H3O plus ions, right? What do we have, right? We have only hydroxide ions. All right, now what do we do in this case? Then we remember, but remember the auto-ionization constant of water, right? So we remember at 25 degrees, we know that our ionization constant of water is going to be equal to the concentration of my hydronium ions multiplied by the concentration of my hydroxide ions, okay? And this would be equal to 10 to the minus 14. Please keep that in mind. Okay, so I'm going to use this constant, right? So what we're simply going to do is say, all right, we want hydronium ions, isn't it? Because that's what we use for calculating pH. So now I'm going to say, okay, but I know I want hydronium ions, H3O plus, okay? But do I have the concentration of my hydroxide ions? Yes, I do. This is multiplied by, what's my concentration? That's 0.02, okay? But remember, this multiplied by that will give us 10 to the minus 14. And remember, ladies and gents, this takes place at 25 degrees. So should they give us another temperature, they need to give us another ionization constant, right? But of course, in most cases, we will be given that value there at 25 degrees, right? And by the way, please remember that you have this in your formula sheet, right? So I want to find the concentration of my hydronium ions, okay? So what will I do? Remember, these are multiplied with each other, so I'll divide both sides by 0.02. But remember, what I do on the left, I need to do on the right-hand side. So divide that by 0.02. Okay, so that cancels out. Okay, so my H3O plus value, we'll just take a calculator just now. So our H3O plus value, H3O plus concentration, right? So let me just take my calculator there and say, well, this is 10 to the minus 14. So that's 10 yx, that's negative 14, right? Okay, and I let me just remove that, make sure that, so that's divided by 0.02. Okay, I get a value of 5 times 10 minus 13, right? Can you see that? Okay, so it means the concentration of my hydronium ions. Okay, let me just write it down on the other side. So the concentration of my hydronium ions, okay, is actually 5 times 10 minus 13. Remember, this is in moles per cubic decimeters. Right. Now remember, ladies and gents, why did we have to go through that? Remember, you cannot calculate pH, all right, when you do not have your hydronium ion concentration. Okay. So now, because we had hydroxide ions, we needed to find the hydronium ions, and therefore that's why we needed to go through this, right? Now we've got our concentration of hydronium ions. Can we calculate pH? Of course we can, right? So it means that my pH value will now be equal to the minus logarithm of our hydronium ions concentration. So as a result, this is minus the log of 5 times 10. Remember, we said that when you substitute, you need to use round brackets. Okay, these square brackets mean concentration in chemistry. Okay, so now let's do exactly that. So that's minus the log of our answer, okay, which was 5 times 10 to the minus 13. I get a value of 12. Okay, I know you can't see that clearly. That's 12.3, right? So I get a value of 12.3. Okay, and so that is our final answer. So pH, remember that pH does not have a SI units. Okay, so as a result, that becomes our answer. All right, I hope that makes sense. Okay, we'll take another example just now. But before I take on another example, let me just show you. Perhaps some of you have seen this before, okay? And maybe not to confuse you. So I hope this makes sense, okay? Now, taking the very same example, remember that we took, or rather we had the concentration of our hydronium ions. Now you can choose for yourself which one of the two methods you want to use, okay? Right, and I don't want to confuse you with the two. All right, this you have in your data sheet, and it makes it easier for you to apply this method. Okay, the other method of using POH is not there in your data sheet, but look, for some people I've heard that they find that a little bit more easier. Now what I'm going to do with you just now is, let me just show you another way of calculating the same thing using another method. Okay, right, I'm just going to take this away. Right, now remember, we already had found the concentration of our hydroxide ions, right, or H, and we found that to be 0.02 moles per cubic decimeters. Okay, so that was moles per cubic decimeters. So we found this concentration, right? Okay, now what some do is they say, well, let's not find pH, but let's rather find POH. Now, what we know is that pH plus POH is equal to 14. Now, this is when we've dropped the logarithms, right? Okay, so pH plus POH will give us 10 to the minus 14. Please, I want you to follow me in what I'm doing, right? So now, how do I get POH? Well, in the same way that you get pH. The difference now is that POH is minus the log, now note, of OH minus. Now, ladies and gents, if you really don't prefer this method, I completely understand. Okay. So it means that I'm going to simply say POH minus log of hydroxide ions. And as a result, now note, I've got the concentration of my hydroxide ions, isn't it? Right? And what is that concentration? It's 0.02. So I am not calculating pH, but I'm calculating pOH. So that's 0.02. Okay. And now I want you to please note. So I'm going to say it's minus the log, okay, of my hydroxide ion. So that's 0.02. Okay. I get a value of 1.69. Look, let's just say 1.7. Okay. Right. I'm going to round off that value. So I get a value of 1.7. All right. Now, please keep in mind, what did they ask us to calculate? They asked us to calculate pH, not pOH, right? But now I know that according to this formula, pH plus pOH is equal to 14. I'm looking for pH, right? But my pOH value is 1.7. This is equal to 14, of course. Now you can see how we can get to the exact same value, right? So I'll say 14 minus 1.7, and this will give us 12.3. All right. Now, for some, they may prefer this method, right? Now, where the confusing part is, and I just want you to note, when I use this one, I use positive 14, but remember the other one where I give you Kw. Remember that we said concentration of H3O plus times the concentration of OH minus is equal to 10 to the minus 14. Now, I really don't like toggling a lot between the two methods because that's where the confusion comes. But I want to put them side by side. If you prefer this method, remember pH plus pOH will give you 14. If you prefer this one, which by the way, this you are given in your data sheet. This one you are not. Okay. If you prefer this one, then we know that it's going to be 10 to the minus 14. Okay. Right. So let's do another example. Let's try another example where I'm going to actually try to explore using both methods. Is that fine? All right, let's go. All right, so let's take this example. This is standard solution of potassium hydroxide is prepared by adding 18 grams of potassium hydroxide and dissolving it in 1800 cubic centimeters of distilled water, right? So remember, just I thought I'd use this example to just remind you of a few things, right? So remember that first of all, when we're talking about a standard solution, we mean it's a solution that has a known concentration, right? So we are preparing a standard solution of potassium hydroxide this time around, and they are using the mass, okay? So just a reminder of stoichiometry again, right? So 18 grams of it, and they're dissolving it in that volume of water. So first of all, they want us to calculate the concentration of potassium hydroxide. Of course, in this case, this has nothing to do with acids and bases. This would be a normal question for stoichiometry, right? So how are we going to get that concentration? Okay, all we're simply going to do is say, well, we know we've got mass, right? We're going to use our concentration to mass formula. Okay, so concentration, that would be the mass divided by the molar mass multiplied by the volume, right? So okay, let's just write it here. Okay, what's my mass? That's 18 grams. What's my molar mass? Okay, that's where I need to go to the periodic table and say, but what's the formula for potassium hydroxide? Okay, so I know that potassium hydroxide is KOH. All right, please let's remember the names of it, of the elements, right? So that's potassium hydroxide. Okay, that's our base, our compound there. So KONH. I go to the periodic table and let's check, right? My K is 39. There it is there. Okay. And then oxygen, we know that's 16 and hydrogen is 1. Okay. So it means to get the molar mass, okay, for potassium hydroxide. So that's molar mass for KOH. It's simply going to be K, you remember that's 39, plus O, that's 16, and H is 1. Okay, right? So that's 39 plus 16 plus 1. Okay, so we should be able to get 56 there. Okay, so that gives us 56 grams per mole, right? So we know in this case it's going to be the molar mass, that's 56, multiplied by the volume. Now, once again, remember that when we use this formula, volume must always be in cubic decimeters, right? Okay, I'm just going to take this up a little bit. So volume must be in cubic decimeters. So this is going to be 1800. Remember, how do I convert it to cubic decimeters? You divide by 1,000, right? So if I take 1800 and divide that by 1,000, okay, 1,800 divided by 1,000, I get 1,8, right? So in this case, that will be 1.8 there. And please remember, all I did for the volume was say 1800 cubic centimeters, divide that by 1,000 to make it in cubic decimeters, and that value gave me 1.8 cubic decimeters, right? So there it is there, and all that we simply do, we'll say 18 divided by 56. Okay, right, so that's 18 divided by 56 times 1.8, right? Okay, so what do we get there? 0.19 0.18. Okay, so that's the value that I get there, 0.18. I'm going to just round it off if you don't mind. Okay, so that's 0.18 moles. Remember, now we are dealing with concentration, so that should be in moles per cubic decimeters, right? So that's moles per cubic decimeters. Okay, right. So now we know that we've got our concentration. So we want to now move on to the next question. They say now determine the pH of the solution. Okay, so let's move on very swiftly. So how do we determine the pH of the solution, right? Do I have the concentration? Remember, to find pH, I need the concentration of my hydronium ions, right? Do I have hydronium ion concentration? Absolutely not. We don't, right? So now what we're going to do, we ask ourselves, first of all, how does potassium hydroxide ionize? Well, potassium hydroxide becomes potassium plus, okay, K plus, and OH minus, right? So potassium hydroxide does not give me hydronium ions. What does it give me? It gives me hydroxide ions, right? So I'm going to simply say, do I know the concentration of potassium hydroxide? Yes, we do. We said that's 0.18. So now I note once again, for every one of this, I will get one of that. Now, ladies and gents, just to let you know, if you remember the case of magnesium hydroxide, if I had something like magnesium hydroxide, if you're wondering why I always insist on this, right? Magnesium hydroxide would have given you 2 hydroxide ions, right? So what would you do for something like this? It means for every one of this, you get twice the number of hydroxide ions. Can you see? So for this one, to get hydroxide ions, you'd actually multiply the concentration by 2. But in this case, we're not there yet, okay? All right, all we wanted to do was for this one. So this one, for everyone, there's 1. So it tells me that the concentration of my hydroxide ions should exactly be the same, right? So that's OH minus, this is equal to the concentration of my hydroxide ions. This should be 0.18 moles per cubic decimeters. Okay, right. So now that I've got the concentration of my hydroxide ions, right? Can I calculate the pH? No, I can't. All right. Now this is up to you which method you'd want to use. Okay. Whether the first one that I showed you, okay, now that we've got concentration of hydroxide ions, you can say, well, I know therefore that H3O plus multiplied by OH minus, okay, this would be equal to 10 to the minus 14. Of course, we are assuming that we are doing this at 25 degrees, right? Okay, so now what would we then say? Would say, okay, concentration of our hydronium ions, that's what we want, okay, but we do have the concentration of the base, which is 0.18. Look at that, I'm using round brackets, which is equal to 10 to the minus 14. And as a result, you can divide both sides by 0.18. Okay, 0.18. Of course, that cancels out. So as a result, H3O plus, right, concentration, I would say, okay, that's 10 to the minus 14. So let's just say 10 x to the power negative 14. Remember, this is minus 14. Okay, and you divide that. Please just make sure that when you're going to use this, you remove the sign from the exponent. Otherwise, if you don't do that, it will put the division sign next to the minus 14. Okay, right, so that's divided by 0.18. okay, so I get a value of 5.55, okay, or let's say 5.56, okay, times 10 minus 14. Okay, remember, okay, I've run out of space a little bit there. Remember, that's in moles per cubic decimeters. Okay, right. Now, can I calculate pH? Absolutely. You can just simply say, now I know my concentration of hydronium ions, so that's minus the log of my H3O plus concentration. Okay, so this is minus log, okay, 5.56 times 10 minus 14, and as a result, what do we get? So I'll just simply say minus the log, okay, of my answer. All right, it was still in my calculator. I get a value of 13.26. Okay, by the way, I didn't mention this in the previous example. Remember that we said the pH of a base has to be greater than 7, right? So obviously potassium hydroxide is a base. Look at that pH. We get a pH of greater than 7, and by the way, it's closer towards 14. So what does that say to us? It actually simply says to us, this is a very strong base, right? So it's closer to 14, so it's telling us that potassium hydroxide is a strong base, right? So that's how we will calculate it. By the way, we can still use, in fact, let me do that just on the side here, just on another piece of paper. So we could have used the one for POH, right? So remember, we already found the concentration of potassium hydroxide, isn't it? Okay, so just to show you the other method, we said POH, okay, is minus the log of our hydroxide ions, right? Please just remember, I'm doing exactly the same question. It's just a different approach. So whether you prefer this one or that one, okay, that's up to you. And maybe I should just give a warning about this one. I'll just tell you what the warning is a little later on. So that's minus the log Okay, OH minus concentration, we said that's 0.18. Okay, so so let's just calculate there. That's minus 0.1. So that's minus the log. Okay, the log of 0.18, and we get 0.744 if you so want. Okay, in fact 0.745. Okay, right, but what do we know? pH plus POH, okay, is equal to 14. Please note a positive 14 this time. Okay, right, so this will be pH is equals to 14, okay, or plus 0.745. Okay, this is equals to 14. I'm going to take two significant figures. That's the lowest that I have there. So pH is 14 minus, okay, I'm just going to, right, and I get exactly the same answer, which is 13.26. Okay, right, so that's my pH value. And please remember that pH does not have units. So whether you prefer this one or that one, that is exactly the same. The only warning that I want to just give with this one is that if you do find that they give you the ionization constant at a different temperature, okay, obviously it will no longer be 10 to the minus 14. It will be whatever it is that they give to you, right? So meaning this one will no longer be applicable. Okay, so to get this number here, obviously you'd have to look at the ionization constant that you're given. Actually, there's a way to get it, but I don't want that to be confusing. Okay, so I want to leave it here whilst you still understand, and then for more questions we'll do some videos. And by the way, you can get in touch with us. I'm going to make videos that are just for members only later on. Okay, right, and you'll be prompted to join if you want to join for our lessons. Okay, but otherwise for now, it's been real, it's been good having you. Okay, see you on another episode of acids and bases. Okay, and please don't forget to subscribe for those of you who haven't subscribed. Otherwise, from me for now, it's sharp, voila.